Hi, and welcome to this video, actually a series of videos where I will be implementing a simple C++ class for handling big integers. I'll call it longer, since long and long are already taken. But why would one do something like that? Because it's fun. There are also a few good reasons. First, it involves some low-level considerations, such as memory alignment and carry. Second, it involves operator overloading. Third, it involves algorithms, notably Knuth's algorithm D for division. And last but not least, it does something useful if you want to perform arithmetic on really large numbers. This is kind of far-fetched today, with 64-bit architectures being common, but it used to be quite relevant not so long ago. Even on a 32-bit machine, integers were plus minus 2 billion or up to 4 billion unsigned, and one could easily run out of numbers. This is less true on a 64-bit machine, and even less so considering that both Clang and GCC support int 128t, but I don't believe it's part of the C++ standard. Still, my point is, hardware support for integer arithmetic has a limit, and writing a library is a nice exercise. This has obviously been done before. There are well-known public BigInt libraries like Boost and GMP. Mine will be certainly less comprehensive. This is what I plan to do. Unsigned only, and probably will do signed one day. No fixed length. It will expand and trim as needed. And I'll do 4 arithmetic operations. And once I've done that, I'll see what I do next. Okay, let's start coding. The first important decision is how the number will be stored in memory. I need an array of standard integers, standard meaning supported at hardware level, and a variable to store the size of the array. My first intuition was a C-style array, like this, and the variable to store the size, but I eventually switched to std vector, and I'll get back to that. So why uint64t? First, it's the largest hardware-supported integer on my Apple Silicon map, and I believe this is the most efficient way to do it, meaning to go with the biggest number you can handle. At the same time, I know that my compiler supports uint 128, which I believe I'll need. So I'm safe from that perspective. But why uint64, which is defined in C stdint? Why not unsigned long? Well, there's some ambiguity in the C++ standard where unsigned long is at least 64 bits, and unsigned long-int, depending on the implementation, is at least 32 bits, while uint64 is guaranteed to be exactly 64 bits. And it's also shorter and faster to type. And at this point, it's important to note that ARM or Apple Silicon is little-endian, and so is x64 and nearly every modern CPU. It means that within a word, the least significant byte is stored at the lowest memory address. Let me show you an example. Humans read numbers from left to right, with the most significant digit on the left and the least significant digit on the right. Well, here I'm assuming that hex is human readable. So when we type in numeric literals, that's also how we type. So I have two variables, high and low, which with bytes being a 1, 2, 3, and so on until OF and 10. Still high, low. But in memory, on a little-endian system, the least significant byte comes first at the lowest memory address. So I have my memory dump from a previous run, and I opened it on the address of the array. The first byte is a 10. This 10 corresponds to the 10 we have here. And then we have OF, OE, OF, OE, and so on. And finally, all the way to O1. O1 being here. And notice that I constructed my array by putting low first and high second. That's because when storing my 64-bit words in the array, I want to replicate little-endianness, meaning that the least significant word to be stored at the lowest memory address, so that the whole memory buffer is a sequence of bytes in a consistent order. Probably there's a different way to do it, but I find it nice to have such order, especially as I was planning to use a C-style array together with some reinterpret costs, which eventually I did not do. I was also thinking about how to resize the array efficiently. Allocating memory on the heap is relatively expensive, so I want to avoid reallocating too often. For instance, an addition or a multiplication could need to expand first to allow space for overflow, but then you may want to trim the array if there was no overflow. The idea would be not to deallocate immediately, and as I was reflecting on that, I realized that std-vector provides all the functionality I need, because it has a contiguous array with lazy reallocation when the size shrinks, and in a true C++ manner with no significant overhead, or probably no overhead at all. I understand that the implementation doesn't rely on a size variable, but rather it has 3 pointers, the first pointing to the beginning of the array, the second to the end of the array, and the third to the end of the allocated memory. And it all comes with some handy features right out of the box, such as safe deallocation and compiler-generated copy and move constructors and assignment operators. So the more I reflected, the more I realized that std-vector was the way to go in modern C++, and I shouldn't be doing C-style arrays. So std-vector it is, and it's the only member variable that I have in my longer class. Therefore, I get compiler-generated constructors for free. I could have written equals default, which would produce exactly the same outcome while clearly stating the intention. What you don't want to do is to declare only some of these 5 special member functions and not all of them. I think this is called the rule of 0 or 5. Assignment operators are very similar to constructors, but there is an important difference. The constructor and the assignment operator are not called in the same context. The constructor is called when a new object is created, and sometimes it's misleading because you may create it using an equal sign, while the assignment operator is called when an existing object is being assigned a new value. The standard constructor is not of great use though, as it creates an empty object. I want two additional constructors. One to create an object with a predefined length, and one to initialize an object with a number, for instance, an unsigned int. This creates ambiguity in the overload, because size t is basically an unsigned int. So my solution was to use an initializeList constructor, which removes the ambiguity and also allows to initialize multi-word numbers. Note that the order of parameters is reversed, as the number is stored with little-endian word alignment, while the natural way to provide parameters is the way we write them. That is, the most significant digit on the left. I also deleted the int overload here and made this constructor explicit to hopefully avoid it being wrongfully called. Okay, I'll wrap it here for today. Stay tuned for the next episode where I'll be doing arithmetic operators. I'll also post my code on GitHub. I'll put a link in the description. And thanks for watching. Bye.